classifier k near class by the classifier class k nearest classifier class k nearest classifier class, right. We have completed this one. So what all parameters it is taken first, it will take you can see here. Let's suppose I want to show here. mm, Let me execute this. Yeah, these are the let's suppose I want to import a scalar sk yeah import a scalar, sorry, from sklearn we can import which one, import import kn. Okay, it is taking time. We can do copy from here only if we want, or any here. Let me copy directly. It is taking time some. Okay. Okay. Why it's not given? Okay. So I want to show you what is a Canaan classifier. So you can see here in this Canaan classifier is nothing but this is a class. I've already described in OOPS class what is the class here. Okay, in OOPS class, we have a n underscore neighbors equal OOPS class, which we have already know that if you are creating only one class, and if you are trying to initialize your class, you have to pass all the parameters, okay, into the constructor. Same as it is here. These are the parameterized constructor. We have already passing n underscore neighbor equals to 5, weight equals to uniform, algorithms equals to auto, leaf size equals to 30, p equals to 2, matrix Minkowski, and matrix underscore param is equals to none. So these parameters we have already discussed one by one. So what we have covered here, let's suppose I have covered these parameters. I have covered these parameters. Okay, I have covered these parameters till it. So what all parameters I have covered here. Okay, so tell me as of now. Right, Anuj, right. This is the default sets. This is the option. No need to set again. This is the default set. Yeah, this is the default parameter, optional parameters. Okay. So we can see here what is the n underscore numbers. We can see here what is the weight underscore uniform. Okay, already described in previous session. If anyone does not know, they can drop me a message. I will describe once again. Okay, and I have already described that auto. So in this auto, I have already described there is three kinds of algorithms internally used. First one is brute force, then KD tree, and then ball tree, KD tree and ball tree. So the difference between KD tree and ball tree is nothing but both are using tree, but internally the ball tree, just like the structure is, they are using Cartesian. If you want to see here, what is the ball tree and what is the, if you want to see here, go to that official websites, K nearest um, skip that. Okay, go to user guide, nearest neighbors, in nearest neighbor. Okay, go to algorithms. So here we can see here we are good with the brute force, carry tree, ball tree. The difference between these two is nothing but you can see here the address of inefficiency of carry tree in higher dimension. The ball tree data structure was developed where carry tree partition data along Cartesian axis. Okay, ball tree partition data in a series of nesting hypershaper. That means internally, as I already described in KD tree, let's suppose we have a we have a B, and we have a C here. These are the three. Okay, so it will calculate the distance between A to B, A to C. They know the distance between A to C, and they know the distance between A to D, and they see here A to C is the distance between A to C is very far, and the distance between C to D is very far. So without calculating the distance, the algorithm will be automatically analyze that hey, the distance between A to D is also very far. So we no need to calculate unnecessary distance. But so the the complexity of this ball KDT is you can see here the complexity of KDT is order of dn log n. Right, this is the complexity. But if you taking about here like in ball tree, Poultry use nesting hypershaper. That means it use that's why it's called like a poultry. It's like a here. Their dimension will be let's suppose there is a one dimension here, there is a one dimension here, and there is a one dimension here. This is the three dimension. Okay, I want to calculate the one points from here. This is our original point. Okay, so I know that the distance between inner this point to this point is very low or very high. This is not expected. So further, the algorithm will be not calculate the distance from here, distance from here, distance from here. Algorithms will be automatically stop the calculation of the distance, and they can say this is our distance. That's why ball tree is ball tree is more efficient than carry tree. But anyhow, in anyhow, you can see here you have to organize the data into the tree. Anyhow, it will be take costly. So ball tree is more costly. The working of ball tree is more costly than KD tree. The working of KD tree is more costly than brute force, but more efficient. Costly, now, of course, ball tree is costly, but more efficient than KD tree. Ashif got it. Ashif got it. How internally you ask me. Okay. So as of now, we have done with these concepts. As of now, we have done with this concept. All right. Then also I have described what is uniform, what is distance. So if weight is equals to uniform means it will be calculated uniformly. Even though the neighbor is very far on the edge, it doesn't matter. Okay. Leaf size is nothing but this is the size of a tree. This is the in tree there is a leaf is there. So how much leaf it will be by default set at this is the 30. P equal to 2 you already know this is for Euclidean distance. Got it? Got it or not? Metric params Minkowski. Yeah. So coming to that next one. Coming to that next one here. What is max or min, Anuj? Not to get your question. So we can see here, and another one is we are good with how to load and understand the data. Okay, I want to show one more thing is data. So earlier, what happened? Like we used a toy data set. We used a toy data set, right? Toy data set means from we load the data from the data sets. Iris data load underscore iris. So we load the data from iris data set. That was the toy data set. But in real life, in practical, you no need to load the data from toy data sets, because either you can load the data from your local machine, okay, somewhere existing files is there, or either you have to load the data from MongoDB or any Hive or any database. Okay, you will fetch the data from any database or local file system or authorized file system or Google Clouds. These are the source, but you cannot use toy dataset. Earlier, I described here, like you can see here, earlier what I described, this is our KNN classifier. So what you are doing here, you are loading this data, loading underscore iris data set. This data set is nothing but toy data set. So this is not a good practice. This is not a good practice. But for your understanding, I used to load the data from toy data set. But in real life scenario, you have to load the data through this way. Either you have to load the data through the local system or MongoDB or datasets. You are getting my points. So you can see here you have to load the data from your Iris datasets. Got it? And one more thing is that you have to take care about one more thing is that machine learning model, machine will be directly not take any any input in the in the form of string. It will be take the input in the form of integer, in the form of numbers only. Got it? Numbers only, not integer, numbers only. Getting my point. So let's suppose, as of now, in our iris dataset, we have a simple length, simple width, petal length, petal width. These are the four inputs you are giving to the machine. On the basis of this four inputs, and you are giving some output also. Okay, that output is Sitosa versicolor virginica, Sitosa versicolor virginica, Sitosa versicolor virginica. So here you can see here, I want to show here, you can see what we are doing here. We are taking here x underscore iris data and x underscore iris. So this data is the numeric form. This is in form of numbers, because form of number. If you want, I can show you. This data is in the form of numbers. This what is this? Principal random forest algorithm should I close it? Okay. That is also minute. Close it. Okay. Okay. So we have to import data sets. Let me copy and post. No need to write again and post. Okay. Actually, I'm moving very slow and slow so that you will get all clarity, from every aspect. That's why I'm teaching very slow. very slow, you know. So we can see here, this is our data set. So let's suppose I want to load my data sets. So you no need to, well, you can see here, I want to show why it's required to convert the data into the number formats. Okay. Same as it is, let's suppose I want to see here x. So you can see here this x input is in our where? In our data, the x input is x is the input, but this is in form of numbers 5.1, 3.1. This is in number format. So it is fine. But if you want to take here x underscore iris, what is the data output was there? Sitosha, Versicolor, Virginica. I want to know here target names. So you can see here. Sorry, I want to put it into the target name is nothing but Sitosa, Vertical, or Virginica. So we cannot train this trend to string by the machine. So before passing this, even though earlier what we are doing here, we are passing direct target because in tried data sets, it has already converted this string into the number. So this is for Sitosa, this 111 for Versicolor, this 222 for Virginica. So this data is already converted. We no need to convert. But somehow, let's suppose you are working with a data which is stored into your local system, file system. So maybe the data is not converted. The output of the data is into the form of a string, into the form of a string. So you have to split that data into the form of integer. You are getting my point. If you want to try, you can pass the data directly in the string form. It will give some error. You can try. I got it. Lakshmipriya got it. Pratik got it. Hey man, you should ask some doubts. I don't know why you are not asking anything. Sneha, Sneha got it. Somehow I want to describe each and everything. Any doubts as of now, Sneha? Sneha, any doubts as of now? Tell me.
No, sir.
Why, sir? Why, ma'am? It any kind of anything you are not getting my point. Pratik, Sai, Sai Swarup. Because sometimes your explanation gives us clear concept. That's why. Okay, good. Right. Okay. Right. Good. So today we'll see what is a grid search. So I want to see here how. So my earlier approach was directly load the data from data sets. This approach is like you have to fetch the data from your local system, local system. So we can see here, this is our data set. This is our data set. In our data set, these are the input. These are the input triple L, triple with petal and petal with is the input, and this is the outputs. Species is the outputs. Okay, even though we can calculate calculate. And there is one more thing is you should remember. Instead of passing input as a data frame, you have to pass input into numpy array 1D, 2D array or 3D array. and output will be also into the array, like a 1D array or 2D array. So instead of passing, you know that 2D array is in data frame, our table is nothing but 2D array. But you should not pass directly that data frame. It will give a performance issue. So before passing that data which is in table format, you have to convert into the which format? 2D array format or one array format. That's it. ND array formats you have to pass. Same as it is for your output also. Like a y values also you have to convert into the ND for array. These are the good practice. You have to check. You have to check. I want to show here. I want to show here. Let's suppose this is my column df dot columns and this is even though this is my data frame. This is my data frame. You know the data frame. You know the series. You know the series. Series is nothing but if one columns and index is there, so that data frame is called the series. Same as it is, what you have to do, like let's suppose earlier what here we are doing. I want to replace because we cannot pass the Sitosa, Vergicolor and Virginica directly to machine. We cannot pass Sitosa, Vergicolor and Virginica directly to machine. You know, because this is a string. Earlier in our toy data set, the data is already converted. The data is already converted into the 0, 1, and 2. But here our output is like a y values in string values. We cannot pass this y values directly to machine. Before passing this y values, what you have to do, you have to convert this data, Sitosha, Vergicolor, Virginica, into the number format. So how can we do that? As we know that we have a one replace function. We have a one replace function is there. Replace. I want to replace Sitosha, Vergicolor, Virginica into 0, 1, and 2. And you have to put here in place equals to true. So now we can see here. Now we can see here y under y dot unique like a instead of all the y values. If we want now the y is converted into the 0, 1, and 2. Once you check the y converted into 0 and 1 into 2. And there is another thing is that let's suppose earlier you can see here this x is our this x values you can see here what is the type of x. So you can see here the type of x is what is, tell me, data frame. The type of x is data frame. The type of x is data frame. So what I suggest, like you no need to write, you no need to pass to machine your data into data frame. It will give performance issue. You have to convert the data frame into the 2D array because this data frame is nothing but table. So you have to convert the 2D array and D array. You know? So how can you convert this 2D array directly? There is one operator values is there. Once you convert, let's suppose I want to convert x 2D array to data frame to 2D array or array. So you have to write only values. How can you convert x dot values? Once you execute this line of codes and once you check the type of this x, you can easily find out the type of this x will be changed into the numpy array, nd array, and you can check the dimension. The dimension will be the 2D array. You are getting my point? You can check here. Same as it is, you know that we have a one series earlier the output is nothing but series because I want to show here Yeah, I want to show here what is the meaning of series is if you have a index is there and only one column is there into your data frame, so the data frame will be become a series. The data frame will become a series if you have an index and only one column. So in our output, like a y, you can see here there is only one column. Cytosha, Virginica, a species is there only one column. So it will looks like a series, right? So what you have to do, like before the you giving to the data to machine, you have to convert into the array format, ND array format. So same as it is, you have to write here y dot values, and this data will be converted. That means this series will be converted into the 1D array. So earlier, whatever the data we have, that was into the form of data frame. All the input data was into the form of data frame. So you have to convert that data frame into the 2D array using x dot values. Earlier, whatever the output was there, that output is in the form of a string. So we cannot pass that string directly to the machine. So you have to replace that string through the any integer values. So we have already converted. Then after that values was in the form of series. We should not pass that series to the machine, series to machine. Before passing the series, you have to convert into 1D array, any array. So same function you have to use y dot values. Once you use y dot values, it will be converted into the. You can see here once again. I'm checking here. Type is numpy dot nd array. I want to check your dimension. The dimension is 1. You are getting my point. So this is the ideal approach. Got it? So before giving the data to machine, you have to do lot of analysis in real time project. Even though on yesterday I have given one same a 2 days workshop in one of the Bangalore college, MS Ramaiah Technical Institutes. So I described lot of projects there in that tutor projects, Walmart projects, and then all. So we can see here, we can see here how before giving the data into the machine, you have to work a lot of for data, lot on data. Somehow data you cannot get the data directly somehow, but as a data scientist, maybe your team is very large. So maybe if you are a data scientist or senior data scientist or principal data scientist, you no need to worry about it. The different data analyst team will be give a data refined data what you have to need. But still, as I described here, this course is nothing but you have to knowledge of Python also. You have to knowledge of data analyst roles also. Then you have to knowledge of machine learning and deep learning and NLP analytics. Got it? Here, next step is you can do this step also. Like these are the previous, you know. But what I will recommend here, these things you have to do manually. Okay, split data into training data and testing your data. I have already described what is the train size, what is the random set, and stratify. Got it? Already described here. What is the balance data? I described here random state. You know that random state is nothing but a seed. A random state is nothing but a seed. A stratify I have already described. What is the balance data? What is the balance data? Balance data is nothing but let's suppose you can see here in our data set we have 50 is vertical. Yeah, 50 is vertical. The number of arrow is 50 is vertical, 50 is setosa, and 50 is virginica. 50 is virginica. Even though in stratify I have taken y. Y means nothing but our cell data 15, 15, 15. Test data actually. Right. So this is our balance data. This is called balance data. So as of now we are good with the splitting. After the splitting we are good with what is static, what is the random state, and what is the balance data. Alright. Then after we can see here. So this is count each class in original data. This is just for your knowledge. No need to worry about it. So next one is feed the model. So how you can feed the model? We have already one method. Feed the model is nothing but you are giving training your machine. Feed the model is nothing but you are giving training your machine. So as of now, what work we have completed? We have imported all required modules. Then we have imported the data and then analyzed the data. Hey, is this data is relevant to our machine requirement? If not, you have to refine your data. Then after step third is you have to split your data into the train and test data. So we have already selected model selection and train underscore test underscore split is there. So we have already we can use this train and train is you can see here we can use which one train underscore test underscore split we can use. In this train underscore is test underscore split, the mandatory parameter is this one, x and y. X and y is nothing but x is our input data, okay, and y is our output data. That means I want to split x also and I want to split y also into two parts. I want to split x into two parts, x train and x test. I want to split y into two parts, y train and y test. That means whatever the data of whole data of x, I want to divide that data into the two parts, training data and testing data. That means whatever the data of y is holding, I want to divide the data into the x train data and test data. And I cannot taking the data from line by line. I'm taking the data here randomly. I'm picking the data from randomly, shuffling. Hey, you place the playing cards. Total number of playing cards is 52. So you can see here before giving the data to each member 13 13, you paste the card. That means you shuffle your card so that it will the probability will be reduced to getting same type of data to each one. So that's why the shuffle is required. Here for shuffling we are taking random state seed. Randomly it will be picked. Then I have already described why we need to stratify for splitting. So after that splitting the data, you can see here, this is the output x underscore train, x underscore test, y underscore train, y underscore test. Got it? Got it? So this is the third step. Once you're done with your data splitting, train and test, then you have to train your machine. Fitting the model is nothing but you are giving a training to your machine. Fitting the data is nothing but you are giving the training your machine. So you can see here, if you are giving the training your machine, you can see here knn.fit method. So what kind of data you have to pass? So you have to pass you train data, whatever the data we have splitting from our training and splitting from our original data x and y, original data, this is x and this is y. So from X, we have a X underscore train data and X underscore test data. From Y, we have a Y underscore train data and Y underscore test data. So what will we do? Like this data is for training. That means I will give this date information. Hey, instead of this X train, this is the output. That means I'm giving the training. I'm giving the training. Hey, 2 plus 4 is your input, and the basis of this 2 plus 4, this is the output. I'm giving the input. 6 plus 8 is equals is input, and the basis of this input, I'm saying that hey machine, this is the output. I'm giving the training to machine. You are getting my point. So once our train, how can you give the training to your machine? That means this is the function. Fit is the methods. Fit is the method. So in this fit, you are passing the values x underscore train and y underscore train. That means you are saying to machine, hey machine, this is the input data, okay, and on the basis of this will be the output. That means it say like hey, if Sitosa length is sepal length is 2.4, sepal width with 1.6, petal length is 1.4, and petal width will be 0.2. So you can see here, this is 0. That means this is nothing but nothing but Sitosa. I'm giving the training. If you have this kind of data, so you have this is the Sitosa. How machine will be identified? You have to thought like let's suppose in early morning you are on walk, okay, in a garden. You are getting one flowers, okay, and you doesn't know this flower is Sitosa or Virgicolor or Virginica. So how can you do manually? You can go your home. You can go to your home, and if you can bring one scale, and then you can measure their petal length, their sepal length, their petal width, and sepal width. You can measure it, and then you find out. Hey, if the measurement is this, so you can see here, this is the Sitosa. If measurement is this value, you can see here, this is the Virgicolor. If measurement is this value, you can see here, this is the Virginica. You have already some parameter is set into your mind or somewhere in any books or any reference. But the machine does not know how to produce the answer. So before, so that you have to describe, hey, these are the X train data, and on the basis of this X train data, this is the accurate output. I'm giving the training. This is the original X train data. On the basis of this training, this is the output. You are getting my point. So this is the all about fitting the model. Fitting the model is nothing but giving the training to our machine. Now the times comes for test. Hey, I trained you 1 month. Now the times comes for testing. What you understood after giving my training? Are you really getting my point or not? So now we can see here step 5, predict level of test data is nothing but testing our machine. Earlier I have given the training, now I want to test my machine. So how can we do that? So for this we have a knn.predict. We have a predict function, we have a predict method. In this predict method, what type of data you should pass? Hey, you can see here what we can see here. This in training I'm giving, in training I'm giving questions also and answer also, because I'm giving the training. In training I can give you, even though let's suppose now right now I'm giving the training, let's suppose it does not know answer, So I will provide answer also. But let's suppose I'm giving the test. Should I provide the answer? Tell me yes or no. Should I provide the answer? Hey guys, tell me yes or no. Ashif, Sneha. Hey man, you are not listening. Question is, let's suppose I'm giving the training. Okay, so in training, if you does not know any answer, I can easily provide the answer also. That means in training, I'm giving the question also and answer also. Question also, answer also. But now the times comes for test. So should I provide the answer also? Tell me. Right, you are right,
Not
Surendra. You
needed.
are right.
Not
Yeah,
needed because already we have provided question and answers, and based on which the machine has to predict its answers for the new set of
yeah,
questions we have given.
right. You are right. Exactly right. So here we can see here we are now the times comes for testing. X underscore test is here. Now the time comes for testing. I want to test. So I'm giving the test result, test data. Whatever the data we have split it into the training and testing, that same data I want to. So here we have split. I want to show here. Yeah, this. So this data I have used for x underscore train and y underscore train. I have used for giving the training. Now I am giving this x underscore test data, x underscore test data. This is our test data result on the basis and respective of this x underscore test data. This is our output y underscore test data. But I want to give this x underscore test to machine. This is the test set. I know, hey, I'm taking your test. I'm taking your test. I organize the test. I know the answer, but I will not explain that answer at the time of test. I know the answer, but I will not explain that. I will not explain the answer at the time of test. At the time of test, I will not explain the answer. Only I will give the test data. Test data is nothing but input. I will give 2.4, 5.6, 6.8, or 7. And I want to know that, hey machine, tell me this values is related to Sitosa or Versica or Virginica. That means 0, 1, or 2. Same as it is, I will giving another problem. Same as it is, I am giving another problem, another problem. Then I want to, so same here, what I'm doing here, coming here, same thing, I'm giving this test, x underscore test data. On the basis of this test, I want to know that output, what machine is giving the output, y underscore print, and I store this output into a variable is called y underscore print. I stored here and print here. So this is our, this is your result. That means let's suppose I organized here one test and you are giving the answer. So this is your result. But actual result only I know. Actual answer only I know. Then let's suppose I am your invigilators, or I'm testing your, now I'm checking your test copy. Now I'm checking your test copy. So how can I check your test copy? First I see first questions. This is the first question, and this is our answer too. This is our original answer. Even though sometimes what happened in interview process, will as in technical, we set our interview question and give to the HR, because HR does not know technical. We'll give only optional values. Hey, if the students will give the answer is true, and your this test is answer is also true, you can say this is the right. So somehow the HR will be match the answer one by one, one by one, one by one. Same as it is, we can see here, this is the machine predicted answer. This one is machine predicted answer, right? And this is my original answer. I want to check, hey, machine is giving accurate answer or not. So we can see here, this is the 2, this is the 2, right? This is the 1, this is the 1, right? This is the 1, but original answer is 2. You are getting my point? So as of now, I have checked 3 question. Out of this 3 question, only 2 question, two answer is right and one is wrong. Same as it is, I will check one by one to finding the accuracy. But here you no need to worry about check one by one. We have a one, we have a one function is here, accuracy underscore score. So in this accuracy underscore score, how to check your score is, you have to check your score is your 100. This is our 100 marks exam. So you have to pass here original data. So this is our y underscore test. This is the original one, and this is our machine given answer. We have to pass here original one and machine given answer. The accuracy underscore score automatically match one by one, and then find the accuracy. So you can see here now the result is 93.333333. Almost 94% answer is right. But let's suppose our business requirement is no, we will not compromise with this result. Let's suppose the business requirement is say like, hey, we cannot compromise with this result. Anyhow, I want to 99% accuracy. Anyhow, I want to do 99% accuracy. I'm not able to. I'm not happy with this result. So how can you do that? So what you can do here, you have to manually do some changes into your setting in the nothing but like you have to change somehow n underscore neighbor is equals to, instead of 8 you can change 6, you can change 5. Then you can change model also, like instead of using auto, you can change brute force, you can change kt tree, you can change ball tree, you know. And then you can see your output. Again you can change and then check your output accuracy. Again you can change and then you can check your accuracy. But this is our problem, we cannot check manually this kind of things. We cannot check again and again and manually this kind of thing. How we know that we should use n underscore neighbor is equal to 8 only? How we know that we should use n underscore neighbors is equals to 5? How do you know? So this is the manual approach is, you can go here and you can create one for loop and we can check here. Hey, our output is instead, let's suppose you are putting in n underscore neighbor is equals to 5. What is your accuracy result? If you are putting here n underscore neighbors is equal to 7, what is the accuracy result? If you are putting here n underscore neighbor equals to, so let's suppose I have a 3 parameters which affects our accuracy. One is neighbors, and another one is algorithms, and another one is distance formula, Minkowski or Euclideans and Manhattan. So let's suppose I'm taking here 10. First I want to take here 1 to 10. Then I want to take here 1 to 10 means first I will put n underscore neighbor equals to 1. Then I will put n underscore neighbor equal to 2. Then 10. So you can see here how it is tedious jobs. Of course we can do manually, but we cannot any times we cannot do. So for this we have one concept is called hyperparameter tuning. Hyperparameter tuning is nothing but it will be automatically adjust our parameter. Tuning is sometimes in radio you can say we adjust the tuning. When I was like 5 or 6 years, no, 7 years or 8 years. So I have a small radio. I usually used to listen that radio. So again and so that time there is only two channel was at the radio also, like some BBC and they all there. So we adjusted that tuning, you know. So hyperparameter next concept is, as of now we are good with that. Even though I described this concept 2 or 3 times, you know. So main thing is how we know that n underscore never should be 8 or 6 or 5. What is the best parameter? So what is the meaning of hyperparameter is the meaning of hyperparameter is nothing but how to adjust your parameter so that our accuracy, our machine will be give a better accuracy as per our business requirement. Hey, if your business requirement is okay with 90% accuracy, so you no need to worry about. But if your business requirement is, hey, we have to give 98% accuracy, so you have to do hyperparameter tuning. You are getting my point. So tell me, as of now, as of step 6, any doubts? Because I will not revise again in. So what I think, like some of guys missed some classes, so that's why I revised the whole concept again. I think now it should it will not any kind of doubts.
Sir, this Surinder here, I have a question.
Yeah, tell me.
When we do the prediction testing on the machine, on the training we have given to the machine on whatever sample data which has been given to it, while doing the prediction test, what if there is a new sample of data which is there in that prediction test data? How the machine would deal with the data? Would that just throw an error, or would that keep that sample aside because it was never trained on that sample of data?
No. You can see here. I think you missed a lot of couple of classes actually, so that's why. Uh, you can see here. Once you check your original data, let's suppose I want to show here. This is our original data, right?
Hmm.
1 second. Okay, so this is our original data. In this original data, sepal length is there, sepal width is there, petal length is there, petal width is there. This is the input data. We are not providing all data to machine.
Correct.
Let's suppose 1 second. Let me describe. Okay, so this is our original data. Once you check with iris data, the in iris data total number of rows is 150. Total number of rows is 150. In this total number of rows, 50 is related to Sitosha, 50 is related to Versicolor, and this 50 is related to Virginica. Right. So from this original data, we are not giving training to entire data on the basis of entire data.
Correct.
We are passing here 0.3 is the testing data. That means automatically remaining data, 70% data will be getting the trained data.
Okay.
That means I give some pattern to machine. I give some because what happened in our training, let's suppose generally the questions which I describe in training, I will not ask in test, but that test questions will be based on the training question. You are getting my point.
Okay. Hmm.
Maybe a chance that question is not directly, not as it is at whatever I describe in training, but you have to some brain, you have to some analysis power, you have to some pattern, you have to observe that pattern. On the basis of that pattern, machine will be give unseen data. Here in terminology, whatever the 70% data is there, this is called, what is the training data is there, in terminology it called like a seen data. That means machine has already seen this, gone through with data. But whatever that this 0.3, that means 30% data, that means testing data is there. This is called unseen data. Machine does not see like what is this test data. Machine is only aware about seen data. Machine fit some patterns into their mind, and then on the basis of that, they are giving some prediction. That's why sometimes that predictions give error. Some accuracy is not up to the 100%. Even though any algorithms will not achieve 100%, will achieve 99.99% accuracy, but somehow will not achieve 100% accuracy. Now it's clear.
Yes, yes, that answered my question. Sure. Thank you.
Or any doubts? Still, if you have doubts, you can ask it.
No, that answers. That's pretty clear.
Okay, thank you. So come up with the hyperparameter tuning. So hyperparameter tuning is nothing but how to find our best parameter. What per instead of n numbers neighbors is equals to 8, if you are passing 6, this is the find parameter or this 8 is the find best one. How we can know like so for this concept is called hyperparameter tuning, you know. So for this hyperparameter tuning, you have to use first approach is like we can use our own code. So how can we do our own code? I want to describe here. We can see here. we can see here. Let's suppose if we are not using, how can we write our own code for knowing that which one is the best parameter. So let's suppose I have created one range here 1 to 20. This is nothing but I'm creating one list value 1 to 20. In k neighbors classifier, firstly I'm passing here n underscore neighbors. I'm passing here n underscore neighbors is equals to I. Means I'm creating, I want to check in n underscore neighbors. What I'm doing here manually, I want to check. Let's suppose in n underscore neighbors is equals to, let's suppose I'm passing 1, I'm passing 2, I'm passing 3, I'm passing 4, 5 up to 20. What will be the accuracy? What extent accuracy is affected? I want to do this task manually. So how can you do that? You know the for loop. You can create one for loop and you can create one range 1 to 20. That means one list is there 1 to 20, and one by one you can pass here. First you pass here n numbers equals to 1, and then you can feed the model, and then you can predict the model, and then you can check your accuracy result. Then you can check your accuracy result. Then you have to pass here 2, then you can check accuracy. If you pass here 3, then you can check accuracy. Then you can pass here 4, then you can check accuracy. Right. So you can see here, let's suppose what you have created here, you have created one RS result set empty list. You have created one list range 1 to 20. That means you are creating one list, the values is equals to 1 to 90. Right. And in k neighbors classifier, instead of passing earlier what I have passed here in KNN, I have passed here 8 directly 8. But I don't want to pass directly 8. I want to pass 1 also. I want to pass 2 also and then check the accuracy. I want to pass 3 and then check the accuracy. I want to pass 4, then check the accuracy. So that finally I will finalize that n underscore neighbors will be 5 or 3 or 4 or 2 on the basis of best result. So we can see here, first we are passing n underscore neighbors equals to 1. That model will be fit and it will predict and check the accuracy result. So let's suppose, as you know that if you will be taking the neighbors is equals to 1, that means you are the only one who are giving that, hey, I am the bad or good. So no one guys can say like I am the good bad guys. No one will be see. No one will say tell this kind of things. If you are only one and I want to know your behavior, so you will be extremely say all the positive attitudes. No negatives you will be described. This is the tendency of human beings. You are getting my point. So here you can see here. So this is not a right approach. You cannot take n underscore neighbors is equals to 1. So here you can see here. Let's suppose I'm passing n underscore neighbors equals to 1. The accuracy is 1. That means 100% accuracy. That means, let's suppose I ask to Anuj, hey Anuj, how much hours you studied? So Anuj will be tell, hey sir, I do study around 12 hours a day. But I want to know that. So Anuj is giving here 100% accurate, 100% positive directly. But I want to check with someone who lives nearest to Anuj. So it will be the better idea. So let's suppose I'm passing here n neighbors is equals to 2. The accuracy is reduced and now accuracy is become 95%. If I'm passing n is equal to 3, accuracy is 95%. Passing 4, accuracy is still 95%. Passing 5, accuracy is 19,77777. That means 98%. So you can see here, you can observe till 19, which one is the best accuracy? Tell me, which will be the become our best accuracy? See here, tell me. So best accuracy is 97,77777. That means 98% is the best accuracy. So how will we finally manage here? You should go with the neighbors equals to 5. It gives a best accuracy. Hey, you are getting my point or not? First tell me. If you are not getting my point, you should ask questions. You should do some yes or no. Don't sit just like a blank. Lakshmi Priya, as of now, any doubts? Any
No,
doubts?
sir.
All
No.
clear? Surender,
Yes.
all clear?
Yes,
Pratik,
sir. Yes, sir. It's pretty clear.
Pratik,
Yeah.
Pratik, all clear? Pratik,
Clear,
okay,
sir.
okay. Ashif, Anuj, Sneha, okay, Sneha, are you there? Swati, are you there? Any doubts? Sai, okay, no issue. So this is only one parameters we are fixing here. We are fixing here. Now I want to change with multiple parameter. How can we do that? Because we understood like there is lot of parameters which will be affect your accuracy. As I told that earlier. As I told you earlier, there is lot of parameters will which will affect your accuracy. So one parameter is that neighbors, another parameter is weight, another parameter is algorithms. So here we can see here. So for this we have to apply multiple for loop. We have a 4 underscore range is there. Okay. So I want to see 1 underscore 11. Then for W in as we know that the weight is only there is two type of weight. Even you can pass here uniform or distance. By default, uniform has been passed, but you can pass anyone uniform or distance. I have already described what is the benefit of distance and what is the benefit of uniform. That means, let's suppose I want to know that here I want to know that this unknown point behavior, this is the triangle or this is the square. So I will give more weightage to nearest people. I will give less weight for far people, like far distant. So if you are calculating the weightage on the basis of distance, so you have to pass here distance. You can go and observe with the KNN classifier and pass a question mark and go through with the official doc string, and where you can find out what is the uniform and what is the distance. Kindly do that if any doubts you have. Then you can see here for loop is there for ball tree, KD tree, and brute. So as we know that we have a three algorithms. By default, the algorithms is auto. That means machine will be automatically adjust which one is the best. Ball tree is the best, KD tree is best, and brute is best. But you don't want to rely on machine. I want to do all things manually. I'm checking here if neighbors is equals to 1 and weight is equals to uniform and the algorithm is equals to brute, the accuracy is 99.99%. I'm checking here if the neighbors is equals to 2 and weight is equals to distance and algorithms is equals to ball tree, accuracy is equals to 90%. So this is the way. Hey, don't think so that we have to use all things manually, all things whatever described, whatever given through the Python package and the SKT file. No, man. In real life, you have to develop your own function as it is, just like a whatever sklearn is working. It should be sometimes. That's why the language is required. If if you don't know the logic, if you don't know how to use for loop and how to use what if and condition, you cannot develop a new things. You know algorithm, that is fine. For developing the new algorithms, you have to know some language. This is the requirement of language. That's why first I introduce the language and then come to the algorithms. So my approach is, first I will introduce into the mathematical terms, then language, then come to the algorithms, and then we'll see whatever functionalities, whatever the methods already defined. So first we'll see our own approach. Then we'll go with system defined approach. You are getting my point? So is this fine approach, or I have to ameliorate my approach? Any suggestion? This is the fine one. Is this fine? Hey, Surender, are you there?
Yes, sir. I'm there.
Yeah, fine one, na? Because I want to show head earlier what happened, like even though this things I designed very soon. Okay, earlier this is my own. Okay, so this is my oldest one, but I thought like I should describe some manual approach and then we should go with the directly. This I have already grid search CV is there. I have already grid search CV is there. Okay, for doing this. But I want to show you how grid search CV also internally works. That's why I'm describing. This is my approach. So that tomorrow, let's suppose I give some I give some new problem, so you will be able to develop that new algorithms, a new approach. This is how the approach is taking. So you can see here, checking multiple arguments you can pass here, and one by one you can check the accuracy, and you can see the score. But you no need to worry about that. You no need to worry about that. We have already grid search CV is there. Grid search CV is there. We'll create one grid. Okay. So first you can see here, we have a one model selection. That model selection name is grid search CV. And in grid search CV, n underscore neighbor, I'm taking here np.arrange 1 to 50. That means I'm passing here 1 to 50 numbers of neighbor. Earlier, manually I'm taking 1 to 20. Here I'm passing 1 to 50, that means 1 to 49 neighbors one by one comes into the grid, param underscore grid. Then we have a grid search CV constructor. In this grid search CV, you have to pass KNN. What is the KNN? KNN means our model. KNN classifier. KNN means our model. You can see here above line of code. What is the KNN here? KNN is nothing but our model. This is KNN classifier is nothing but our model. This is our KNN. KNN means after KNN means this is the KNN classifier. Initialize object. So I'm passing here KNN, right? And then I'm passing here parameter grids, whatever grids 1 to 50 in n underscore neighbors I have taken, I'm passing here param underscore grid. Then search CV, I'm passing here 5. So what is CV, what is error score, and what is estimator? Estimator is nothing but the algorithm's name. KNN classifier is there, KNN regressor is there, unsupervised is there, estimator is nothing. So in tomorrow class, we'll see from here onwards, because from here onwards. So today, what you can do here, you can try with manual work. You can try with manual work how to adjust your parameters, hyper parameter tuning. You can try with the manual one. I'm not sharing this code because you have to force you have to think how to write a for loop and how to observe. Can you do that? Can you do that? Can you write your own code? Pratik, can you do that? Ashif? First try your own. Yes, first try your own. I described first try your own. Okay, if you're facing any issue, then let me know. I hope this session is give a very quick recap up to up to what I have covered in machine learning. So up to till okay, from phrase I have started this session from first to till points I have completed each and everything. Getting my point? Any doubts? Any doubt? Still you have any doubts? Lakshmi Priya, Surender, any doubts? Shai, Swati?
No, sir. No.
Okay.
No, sir.
Ashif, any doubts? Good. Thank you so much. Same as it is, we will grow slow, so that all concepts should be memorized. So once you completed, you no need to worry about what is train and test and what is. That's why I'm repeating again and again, so that after the end of this training, each and everything it should be memorized 100%. No need to worry about what is pen test, what is KNN, and what is uniform. Hey, what's described in 2 months before. You no need to think like that. So my approach will be after 2 or 3 days, I will describe previous concept also, because if you are growing you should do practice your previous concept also. So continuous practice is very required. Got it? Thank you so much.
Thank you.
Thank you.
Thank you, sir.
Thank you so much.